Hi guys, welcome back to the channel. In our previous videos, we have already seen what are threads, why are they needed, and what benefits do they provide over processes. Data sharing amongst thread is easier as compared to process, but we have to take into consideration synchronization among multiple threads. We have seen synchronization using mutex and condition variables. In this video, let's look at an example program where we'll be using all of the concepts that we learned in the previous video. We are going to synchronize two threads using mutex and condition variables. Both of them would be doing separate tasks of printing something onto the console. Let's get started on this one. Let's look at this program where we are implementing two threads. One of the thread prints even number and one of the thread prints odd number. Both of them have infinite while loop and they issue print statements inside the while loop. Let's look at the print even thread function first. It acquires the pthread mutex lock and checks for init to be a even number. Init would be set to 1 initially, so this condition would not satisfy and it will break off this if condition and do a unlock on the mutex. Since this is a infinite while loop, this thread can spin again into the while loop and do a mutex lock, fail on this condition, do a mutex unlock again. Let's look at the possible places where context switch can happen. If context switch happens before mutex lock call and print odd thread starts running, it will be able to acquire the lock. This condition would satisfy and it will print the odd number on the console and increment init to 2. At the end, it will unlock, and this thread can also spin again due to the presence of infinite while, but it will not print init onto the screen because init currently is a even number and this condition would never satisfy and it never goes into this if block. Even if it spins again and again, it will never be able to execute this printf statement. Let's look at what happens when the context switch happens here. Let's assume we are in a state where init is equal to 2. If context switch happens here, print odd would try to acquire the lock and will never be able to lock the mutex because mutex currently is being held by the print even thread. The print odd thread would block on this statement. Only once the print even thread does a unlock and switches context to print odd thread, this statement would unblock. Print odd thread would have the mutex now and can evaluate the init variable. Such a program is acceptable. The only problem with both of the thread is that they both are spinning infinitely inside this while loop. Both of them are wasting CPU cycles. With that, what I mean is, let's take init being 3. If print even thread acquires the mutex, it will never be able to satisfy this condition. It will unlock the mutex and spin again. It keeps spinning again and again until a context switch happens. Init is incremented to a new value and then only can this if be evaluated to true. So before init satisfied this condition, there are chances that print even thread keeps spinning again and again in this while loop. If you would have seen my last video, by now you would know how to solve this problem. Condition variables are the solution to this problem. We are going to add a condition signal after pthread mutex unlock in print even thread, and in print odd thread we are going to add a condition wait, giving it the mutex and the shared condition variable. We also need to modify this if condition. Instead of if, we are going to put a while condition here and check for init being a even number. What this means is, if init is a even number, this thread would go into a condition wait. We also need to remove this printf from here, and we can add the printf to be after the while loop. With this, let's look at the flow of the program where init has a state of 2. Let's assume print odd starts running. It takes the mutex, evaluates this condition, and this condition is satisfied and issues a condition wait call. From the last video, you would have remembered that condition wait unlocks the mutex, checks the condition variable. If it has been signaled, it unblocks, otherwise it goes back to sleep in the blocking state. In this scenario, condition wait would unlock the mutex, and since condition variable has not been signaled, it goes back to sleep. The mutex is now unlocked and this thread is in a sleeping state. Print even is going to take control and start running. It can take the lock on the mutex because print auth thread before going into sleep has already unlocked the mutex. It checks for the init variable to be a even value, which in this case is true. It prints 2 onto the screen and increments init to 3. It then unlocks the mutex and issues a condition signal call. As soon as condition signal is issued, condition wait, which was in the sleeping state, can now unblock. Just after unblocking, it tries to relock the mutex. This is the third step of condition wait. It will be able to lock the mutex because we have signaled after doing a pthread mutex unlock. The mutex now is owned by print odd thread. This while condition evaluates to false and this print statement would be issued and 3 would be printed on the screen. After printing 3, it would have also incremented 3 to 4. Now when it comes again and runs again, this while condition would evaluate to true and it will go back to sleep as part of condition wait. A new condition signal would have to be issued after this print statement. In this print, the value would be incremented to 5 and a condition signal would be issued. Once a condition signal is issued, this while loop would evaluate to false because init would have been an odd number and printf would be executed and would increment this 5 to 6. I know this is a little complex, but once you understand this becomes easy. I have summarized the print even function. The basic idea is it takes the lock, and if the init variable is even, it prints it onto the screen and does an increment on the init variable. The init would now be a odd number, and after unlock, the even thread would issue a signal which would cause this wait to unblock. Once this wait unblocks, it prints the odd number onto the screen and increments init. Init would now again become a even number, and even if this thread runs again, it is going to block on this wait call. There is a slight correction here. This should be a while loop, not a if condition. This is because this wait unblocks in case of a odd value, prints it onto the screen and then does an increment. The variable now becomes even, unlocks, and even if this thread is scheduled again as per this while condition, it will go back to waiting state. This is also a important point to note that we always recheck the state that we want the shared variable to be in once we exit the waiting state, maybe due to a signal. This is needed so that we go back into sleep in case of spurious wake-ups. We don't want to do any work if the shared variable is not in the expected state. I'm going to add this program to a GitHub repo and post the link of this repo in the description. You guys can download the source code, have a look at it, and maybe do a dry run on your own to have a better understanding about mutex and condition variables.